Good morning, students. So in this class, I am going to explain a very important problem related to the combination of lenses. See here, so this type of problems usually you can find in NEET level question papers. So this is very important question for your examination, and also this concept is very important for competitive exams also. So I request from all the students, please watch this video carefully and try to understand how to solve this type of problem. See here, I have taken problem number 18. So, and one problem number 17, I will solve after solving this problem. Problem number 17 is a very simple problem. So, I will solve that later on. So, first I want to discuss about the problem number 18. So in the problem number 18, so first of all I want to read this problem. Two thin double convex lenses of glass are placed in contact with a drop of water between them so that water forms double concave lens. If each of the four surfaces has a radius of curvature 0.24 meter, what is the nature and focal length of the combination? To understand this problem, first of all, we have to write the diagram of the convex lenses. Say this is a first convex lens, and one more convex lens we have to take, second convex lens, and that two lenses are contact in this way, such that the space between the two lenses are filled with water. So this is the region where the water is placed. See here, this is the first lens of focal length f1. This is the second lens of focal length f2. And these two lenses are made by glass material. Because the refractive index of glass is given here. Convex lenses are made by glass, and these two lenses are placed coaxially and they are contact each other. And the space between two thin lenses here, this region is covered with the water. Now this water acts like a lens, but that lens is concave lens. So this concave lens is having focal length f3. This is convex lens. First convex lens of focal length f1, this is second convex lens of focal length f2, and this is a lens formed due to the presence of water between the two lenses. That's why, and this is having focal length f3, let us assume that. See here, this lens is made by water and the first and second lens is made by glass material. Now, in this problem, what is the nature and focal length of the combination? Collectively, these three lenses behaves like a single lens. So, in this problem, we have to calculate the focal length of the single lens. Combination of the single lens. All the lenses are collectively called as focal length, effective focal length, that we have to calculate, and also what type of length it can behave. So, we have to find that one. So, for that, you list out the given data. First of all, we have to find the focal length of first lens, and then focal length of second lens, and the focal length of third lens. In the first case, I will consider focal length of L1 I will consider. L1 is lens 1, this is lens 2, and this is lens 3. Right? Now to find focal length, see here, radius of curvature is given. Since all the four surfaces, first surface, second surface, third surface, and fourth surface, all the surfaces should have the same radius of curvature. That value is equal to 0.4 meter according to given data. So that's why first radius of curvature for this surface is R1. R1 is positive we have to consider, because you know what is the procedure we have to follow while taking the sign convention. I was explained so many times in the previous problem. Just go through there. See here, 0.24 meter. R2 we should take negative, you know that. Same value 0.24 meter. R1 and R2 is given. We have to find focal length, and refractive index of glass is given. So refractive index of glass Ng is equal to how much? 3 by 2. Ng is 3 by 2. And we have to find focal length F1. F1 is the required quantity. In the first case, we have to calculate that one. To find focal length F1, so there is a formula, you know that length maker's formula. So length maker formula is 1 by F, 1 is equal to Ng minus 1 of 1 by R1 minus 1 by R2. Very simple. Just substitute all the values, we will get the focal length of first lens. So to find focal length of first lens, in this case 1 by F1 is equal to Ng. So Ng is given here. So what is the value of Ng here? 3 by 2. 3 by 2 minus 1 into 1 by R1. 1 by R1 minus 1 by R2. So R1 and R2 are same magnitude, but here it is negative sign. So R2 is a minus of minus, it will become plus. So finally it will become 2 times R1 and R2 same value. So 1 by R1 plus 1 by R2, it will become 1 by R plus 1 by R. It is 1 by 2 by R. R value is 0.24. 0.24. I will reduce one step here. Directly I was taking. So we simplify this one. You know how to simplify this, which is equal to 3 by 2 minus 1 is 3 minus 2 divided by 2 of 2 divided by 0.24. 2 to get cancels. 3 minus 2 is 1. It will become 1 divided by. So 1 by F1 is equal to 1 divided by 0.24 only. We want F1, that's why we have to take the reciprocal of this value. So which implies the value of F1 is equal to, what is the value of F1 now? 0. Take the reciprocal, that's it. 0.24 meter. So then with the help of this, we have calculated the focal length of the first lens. So according to given data, the second lens is also having same radius of curvature, and it is also made by same glass material. That's why obviously if radius of curvature is same and the material is also same, obviously the focal length is also same. So that's why no need to calculate that one. So we can write like this. Similarly, the focal length of L2 is found to be, so what is the value of F2 is also same thing. I told the reason, because radius of curvature of the second lens and the material is also same, that's why the focal length is also same. We are getting same value, 0.24 meter only. So this is the focal length of the second lens. Now we have to find the focal length of third lens. So to find the focal length of L3, I will consider L3 is the lens formed due to the water. Therefore, according to given data, R1 is equal to plus 0.24 meter, R2 is equal to 0.24 meter, and refractive index of water. See here, the lens is made by water, not glass. This is very important thing. You have to remember carefully. So refractive index of water is 4 by 3. So while taking sign convention, this is also very important. See here, this is the first curved surface for the water. So for this curved surface, we have to take negative sign. So that is very important. So R1 is negative, R2 is positive. This is second curved surface. Second curved surface has to be taken as positive according to sign convention. So therefore, the formula can be written as 1 by F3 is equal to, I used to say, take the same formula here, lens maker's formula. It will become NW, we have to consider, refractive index of water, minus 1 of 1 by R1 minus 1 by R2. So substitute all the values, we will get the focal length of water lens. 1 by F3 is equal to NW. NW is 4 by 3 minus 1 of same value. Now 1 by R1 is minus. Here minus 1 by R1. Minus 1 by R1 only you have to take, or 1 minus 1 by R minus 1 by R. It will become minus 2 by R. What is the value of R here? 0.24 meter. So simplify this one in the next step. So it will become 1 by F3 is equal to 4 by 3 minus 1 is 4 minus 3. It means 1 by 3. 4, 3 is LCM. 4 minus 3 whole divided by 3, it will become 4 minus 3 is 1, 1 by 3 into minus 2 divided by 0.24 meter. Now you simplify this one. To simplify this one, I will consider 1 by F3. 1 by F3 is equal to, see here, it will get cancels now. 2 divided by 0.24 can be written as 24. 2 by 24 is nothing but it is 1 by 12. It can be written as 0.12. So 1 divided by 3 into minus 1 divided by 0.12. Now we multiply these two. So it will become 1 divided by F3 is equal to minus 1 divided by 36 it will become. It means 0.36. 0.36. 12 3 is 36. We have to place a decimal here after two values. It means 36 means 0.36 minus. Then if we take the reciprocal, F3 is equal to minus 0.36 meter. See here, the focal length of the lens formed by using water will be equal to minus 0.36 meter. See the next step. We have to find what is the nature and combination of the focal length. So, if I take F1, F2 and F3 collectively, then it is acts like a single lens. So, that lens is having certain focal length. That focal length is called effective focal length. Effective focal length of the combination can be calculated by using the formula. So you are familiar about this effective combination of the lens. So there is a formula. If two thin lenses are contact coaxially, the formula can be written as 1 by F is equal to 1 by F1 plus 1 by F2. So this is what the formula. 1 by F is equal to 1 by F1 plus 1 by F2. If two thin lenses are taken, here how many thin lenses are taken? 3 lenses, 2 glass and 1 water. That's why it is 1 by plus 1 by F3 we have to consider. Now substitute all the values. You already calculated what is the value of F1 and what is the value of F2, and we got the value of F3. Now substitute all the values, you get 1 by F is equal to 1 by F1, 1 divided by 0.24 plus only 1 by F2, 1 divided by 0.24 only, because F2 is also having same magnitude of focal length, minus here. Because it is F3 is a concave mirror, concave lens, it is 1 divided by 0.36. Now you simplify this one. 1 by F is equal to, you can use the calculator or you can use your common sense to simplify this one. If I multiply and divided by 100, it will become 100 divided by 24, plus here also 100 divided by 24, minus here it is 100 divided by 36 we are getting. 100 is common. 1 by F is equal to, it can be written as 100, 200. It will become same value. 200 divided by 24 is common. 2 times 100 by 24 means 200 by 24 minus 100 divided by 36. Right? So 1 by F is equal to, you simplify this one by using calculator. So if you take the common factor, so 100 is common factor, here 3 is also common factor. 24, 3 times we have to consider, 200 can be written as 100, into 2 divided by 24 can be written as 8 3s are 24 minus 100 divided by 36 can be written as 3 times if I cancel, it can be written as, or better you go for directly, you can use the calculator, it helps to simplify this one. If I simplify this by using calculator, we will get an answer of, so directly if I want to take 2 divided by 0.24, we are getting 8.33 here. 1 by f is equal to 8.33 minus 1 by 0.36. 1 divided by 0.36 can be written as 2.77. If I subtract these two values, 1 by f is equal to 8.33 minus 2.77. We get an answer of 5.56. Actually, this is the power of this combination of the lengths. If I take the reciprocal, then we will get a focal length. F is equal to, if I take the reciprocal of that, 1 divided by 5.56, we get an answer of 0.18 approximately. So this is a distance measured in meter. So the SI unit of focal length is meter. Now, see in this problem, we have taken two thin lenses of focal length f1 and f2 are calculated, and f3 is a water lens which is made by a water. So we got an equation of focal length f3 is equal to minus 0.36. The reason for that is the third lens behaves like a concave lens. See from the final answer. See here from the final answer we are getting positive answer. So the value of f is equal to positive means by combining all the three lenses, the resultant lens is acts like a convex lens. The nature of the combination becomes, so we have to tell what is the nature of the combination. Since we are getting positive value here, positive value is what type of lens we are getting positive value? It is for convex lens. Then finally the nature will be convex lens. This is the nature of the lens what we are getting if two thin lenses are combined such that they are contact coaxially and the space between these two will be filled with water. See, this type of experiment we are going to conduct in the practicals also. There, by using parallax method, we are going to determine the focal length of the given convex lens, and also there we are going to calculate the refractive index of water, right? So first of all you copy this one and I will go for the problem number 17 parallelly. So first I request from all the students to copy. Welcome back students. I will go for the problem number 17. Just I want to read this and list out the given data. A convex lens is to be used to throw on screen 10 meters from the lens the magnified image of an object if the magnification is to be 19. Find the focal length of the lens. See here, from the convex lens, the object distance is given. U is equal to 10 meters. U is equal to 10 meters. And the resultant focal length is given. The resultant focal length f is equal to, focal length of the lens is, magnification is given. The end magnification m is equal to 19. Magnification is a unitless number. So in this problem, we need to calculate the focal length of given lens. See here, this is what the problem what they are given. Say it is a convex lens, and this is what the principal axis. See, we are getting the distance of object to the lens. This is what the distance. This distance is u is given. You have to take negative here. We know the reason for that. If distance is given and a screen is placed at certain distance, if screen is placed at certain distance, the image is formed. See here the image formation. This is what the image formation. The inverted image is formed because it is a real image. Here the screen is placed to observe this image. To find the focal length of this lens, see here magnification is given. So here the magnification m is equal to 19 we are getting. So magnification, you know that magnification m is equal to image distance divided by object distance. See here, image distance is not given, only object distance is given. At that time, so in the previous videos, in the theory I was explained, with the help of focal length, one can find the magnification. It can also be written as magnification m is equal to v minus f divided by m. So this is the formula you have to remember to solve this type of problem. If u is given, object distance, u minus f. See here, it is object distance or image distance what they have given here. A convex lens is used to throw on the screen 10 meters. Used to throw on this 10 meters means screen position is given. U is not given. V is given actually. So it is V. According to given data, V is given. U is not given. So focal length we want to find focal length. There is a relation between U, F and M. So that's why directly you can use this formula. So magnification is equal to U minus F, not U. V minus f divided by f. So to simplify f, magnification is given 19, which is equal to V. V is equal to minus 10 minus f divided by f. You take the cross multiplication. 19f is equal to minus 10 minus f. If I transfer from here to here, it will become, say magnification we have to take negative. The reason for that is why we have to take negative. It is inverted magnification. Magnification should be taken as here, or else you go for only magnitude and cross multiply this. If I transfer, it will become 20f is equal to minus 10. Then what is the value of f? F is equal to minus 10 divided by 2. F is equal to minus 10 by 2. It means f is equal to minus 10 by 20 is equal to 1 by 2. 1 by 2 is minus 0.5. Actually, focal length we are getting negative. See, for convex lens we have to get positive focal length. That's why we have to consider this image distance. So here V is not minus. Sorry, object distance is positive. Negative, image distance is positive only. That's why we are not supposed to take minus 10 here, it is only positive only. Now we clear now? Since we have taken image distance is along the direction of the incident, that's why it is positive. Here it is plus only. So very simple problem. You have to remember this formula, magnification is equal to V minus F divided by F. If instead of given image distance, if the object distance is given, the formula is different. Then the formula can be written as m is equal to f divided by u minus f. F divided by u plus f there will get, not minus. So this is what the formula, m is equal to f divided by u plus f there. This is the magnification, the relation between magnification, focal length and the object distance. Now in this problem, we have to use this formula, m is equal to v minus f divided by f. So copy this problem number, this is the problem number 17 solution. Solution of problem number 17. So I request from all the students to copy this one. V is equal to 10 meter, M is equal to 19 only, because no unit for magnification. By substituting this, we will get the answer for that. So I will go for the next problem, that is problem number 19 shortly. Okay, welcome back students. So I will go for the next problem, that is problem number 19. See, in problem number 19, we have to use again lens maker's formula only. Here, to use lens maker formula, we have to find the power. Power is equal to reciprocal of focal length. That's why P is equal to 1 by F, but 1 by F is equal to N minus 1 into 1 by R1 minus 1 by R2. See, according to given data, a convex lens has focal length. Convex lens has focal length as given. So what is the focal length of convex lens? F is equal to 0.1 meter in air medium. If it is placed in air medium, say it is a convex lens. If it is surrounded by air medium, now the focal length as becomes F is equal to 0.1 meter, which implies its power is reciprocal of this value 1 by F. 1 by F is equal to 1 divided by 0.1. 1 divided by 0.1, you know that. It is 10 diameter. If it is surrounded by air medium. Now what happens if the same lens is immersed in a water? Completely immersed in water. Now the surrounding media is water. It is NW. This is made by Ng. Now the power obviously changes. So we have to calculate what will be the change in power. To find the change in power, now we have to find the power of the same lens when it is inside the water. So when it is inside the water, the power should be calculated. Let us consider the power is FW, we consider. I mean focal length of this lens is FW. See, focal length changes means power is also changes. So first of all, I want to find the focal length, and then you take the reciprocal of that focal length, you will get the power. So for that, to find the FW, 1 by FW is equal to N minus 1. The important thing here it is, now the light is traveling from water to glass. This is very important. Don't forget to write this. Of 1 by R1 minus 1 by R2. But the problem is, here radius of curvature is not given. Radius of curvature is not given. That's why what we have to take, if the same lens is placed in air media, the radius of curvature is also same. I already told in the previous problem, if the lens is placed in air media or else if you place any other media, the radius of curvature does not change. Only thing is, because of due to change in the refractive index of the surrounding media, its focal length changes. If focal length changes, only power changes, radius of curvature does not change. That's why I will use the same formula for that air medium, F of 1 by F. I will consider this is the focal length of a convex lens when it is surrounded by air media is Fa. So it is Fa, which is equal to, formula is Ng only, because it is surrounded by air media, it is absolute. Now Ng is called absolute refractive index of 1, Ng minus 1, 1 by R1 minus 1 by R2. If I use both the equation, no need of R1 and R2, it will get cancels. See here, to find FW, Fk is given, and Ng and Nw is also given. So if I take the ratio of these two equations, say it is equation number 1 and this is equation number 2. So I want to take the equation 2 divided by equation 1. Now in the next step, equation 2, equation number 2 divided by equation number 1. So equation 2 is 1 divided by Fa whole divided by, equation 1 is 1 divided by Fw, left hand side is over. In the right hand side, these two get cancelled. So I won't write this because R1 and R2 is same in air media and also in water media if the same lens is placed in water. So in the numerator we have to write Ng minus 1 because equation 2 is first we have taken Ng minus 1. In the denominator, Nwg minus 1. Nwg can be written as refractive index of second media with respect to first media. Which is second media? Glass. Which is first media? Water. Say glass is second media, water is first media. Light is traveling from first media to second media, then you have to take refractive index of second media with respect to first media. Ng divided by Nw you have to take minus 1. Now substitute all the values. So if I simplify this one, it can be written as Fw divided by Fa. It will go to numerator, it will come to denominator, which is equal to Ng. What is the value of Ng here? 3 by 2. Substitute that value. 3 by 2 minus 1 divided by Ng divided by Nw. Ng is 3 by 2. Whole divided by means you have to take the reciprocal of this. 3 by 4 minus 1. Simplify this one. So 3 by 2 minus 1 you know. Fw divided by Fa is equal to 3 by 2 minus 1 is 3 by 3 minus 2 divided by 2 whole divided by. So 3 3 is a 9 minus Sm is 8. 9 minus 8 divided by 8 only. So very simple simplification. You go for the simplification. 3 3 is a 9. 2 4 is a 8. So LCM is 8. 9 minus 8. So 3 minus 2 is 1. 9 minus 8 is also 1. Then the formula becomes Fw divided by Fa in the next step, which is equal to 1 by 2 whole divided by 1 by 8. 8 by 1 I have to take. Since I have taken multiplication, I have taken instead of taken division, I have taken multiplication. So the formula can be reduced as Fw is equal to Fa into 8 by 2. 8 by 2 is how much? 4. The value of 8 by 2 is 4. Then Fw is equal to Fa. Fa is how much? 0.4. I mean 0.1 into 4 is 0.4. Now the focal length of the same lens when it is immersed completely in a liquid, whose focal length increases 0.4 meter. This is the new focal length. Then new power, the power of the water, if the same lens is placed in a water, whose power is equal to 1 by Fw only. So which is equal to 1 divided by 0.4. So 1 divided by 0.4 is, it is 10 by 4. So 10 by 4 is nothing but Pw is equal to 2.5 diopter. D stands for diopter. This is the SI unit of power. You should remember carefully. If it is SI system only, then only it will converts into diopter. If you are taken in centimeter, you never get the value of the power in diopter. So very important thing. If it is in meter only, then if you take the reciprocal of that value, that is converts into a SI system called the power is measured in diopter. Now, according to the given problem, what we need to calculate? Change in power. To find change in power, delta P is equal to the power of the lens in air media minus power of the lens in water media. So which is equal to, it is power of the lens in air media is 10 diopter. Power of the lens in air media is 10 diopter. Power of the lens can be calculated by taking the reciprocal of focal length if it is in air media minus. Now we are getting 2.5. So if I subtract these two values, it is 7.5 diopter. So this is the change in power. See, the power changes. Suppose if somebody is using optical lenses or spectacles for the observation, if the person is immersed in a water, he is not capable to see the objects inside the water clearly, because whatever the lens the person is wearing, whose lens, the focal length changes. If focal length changes, the power of that lens is also changes. So that's why the surrounding media plays a vital role around the lenses. If the surrounding media is having higher refractive index than the convex lens, it behaves like a concave nature. Or if it is a concave lens, the surrounding media is greater than the refractive index of the lens, then the concave lens behaves like a convex lens. It is completely inverse lens. Diverging lens becomes the converging lens, and converging lens becomes diverging lens if the surrounding media is greater than the refractive index of the given lens. So you have to remember these points for the CET concepts, right? So in this problem, we have calculated change in power. If it is in air media, 10 diopter. If it is in water media, it is 2.5 diopter. Then how much the change in power? It is 7.5 diopter is the change in power. So I request from all the students to copy this one I will go for the next problem, that is problem number 20. Okay, welcome back once again, students. So now I am going to explain the problem number 20. See here in problem number 20, the focal length of convex lens is 0.15 meter. A liquid lens is formed between a plane surface and one face of the lens. So this is what the diagram according to given data. Convex lens is given. A focal length of convex lens is given. What is the focal length of convex lens? F is equal to 0.15 meter. Now, how the lens is placed? A liquid lens is formed between a plane surface and one face of a lens. See here, a liquid lens is formed here. Here, if I place a glass, plain glass, and the space between the plain glass is and a lens is filled with water, it is not biconcave lens. It is plano-concave lens. This lens is made by liquid. So this lens is having focal length f1. I will consider this lens is having focal length f2. This is f1 is given 0.15. We have to calculate f2 because according to given data, calculate the focal length of a liquid lens of refractive index, and also we have to calculate refractive index. So focal length of liquid lens is f2. We have to calculate f2. We have to calculate, and refractive index of N2 we have to calculate. So to find the focal length f2, see if I collectively taken, so how many lenses here? Two lenses. The first one is glass and second one is liquid, water lens, or it is some liquid, we don't know the refractive index of that. By combining these two, the resultant focal length f is given. F is the focal length of these two lenses. See here, the converging combination. So this is also important. Converging means it acts like a convex lens. It acts like a convex lens means the focal length we have to take as positive. Here, converging combination shows the focal length of 0.3 meter. So the focal length of both the lenses by combined, that is what we call them as the resultant focal length, f is equal to 0.3 meter. So we know that there is a formula. 1 by f is equal to 1 by f1 plus 1 by f2. Use this formula to calculate f2. f1 is given, f is given. So then the formula can be simplified as 1 by f2 is equal to 1 by f minus 1 by f1, which is equal to 1 by f. F is also positive, f1 is also positive because this is convex lens. The combination is also behaves like converging. Converging combination. The meaning of converging combination means it is behaves like a convex lens. So 1 divided by, what is the value of f? 0.3 minus 1 divided by f1 is 0.15. If we simplify this one, we get an answer of 0.3. 1 by f2 is equal to, if I take 10 divided by 3 minus 100 divided by 15, 10 by 3 common, 10 by 3 is common, 10 by 3 is common, here it is remaining term is 1, minus 10, if I take 10 as common, the remaining term is 10, 10 into 10, 100. If I take 3 as common, 5 3s are 15, that's why 5 is the remaining term. So 10 by 5 is 2 only. So in the next step, we can write 1 by f2 is equal to how much? 10 by 3 into 1 minus 10 by 5. 10 by 5 is 2. It means minus 1. You will get 1 by f2 is equal to minus 10 by 3 only. So then f2 is equal to 3 by 10 with negative sign. So the value of 3 by 10, so 10, 3.10 so the value is f2 is equal to minus 0.3 meter. This is the focal length of the given water lens. It is plano concave lens formed due to the liquid. We cannot say it is a water only. Now we'll decide whether it is water or some other liquid. To find the refractive index. So to find refractive index, which formula is suitable? We want refractive index. Focal length, we know that, right? If focal length is known value and radius of curvature is also known. So if radius of curvature is known, see, the important thing is, say it is the first surface, it is plane, R1 is equal to infinity. For plano convex lens, one surface should be having infinite focal length. This is very important, you have to remember. This is the second surface due to the formation of this lens. R2 is given. What is the value of R2? 0.1 meter. See here, R1 is infinity. R2, we have to take this surface. This surface is taken as along the direction of incident, right? It is a positive value. So R1 is infinity, R2 is 0.1. The important thing we have to remember is for plano, concave or convex, whatever it may be, for plane surface, the radius of curvature should be infinity. I told already in the mirror topic. For plane mirror, the power is 0. Why the power of plane mirror is 0? Because whose radius of curvature is infinity, reciprocal of infinity is always 0. You know that. Then the formula 1 by f is equal to n minus 1 of 1 by r1 minus 1 by r2. So this formula helps to find the refractive index. I will call this as refractive index N2 because it is made by liquid. So we have to find substitute to F2 because focal length of liquid lens we have to take. So in the next step, if I substitute the values, 1 divided by, what is the value of F2? F2 we are getting minus 0.3, minus 0.2. Why we are getting minus here? See here, it is a concave nature. The lens is concave nature, that's why we are getting minus, which is equal to N2. We have to calculate to find N2. Keep as it is, N2 minus 1 of what is 1 by R1? R1 is infinity. 1 by infinity. You know that any number by infinity we have to take as 0 minus 1 divided by R2. R2 is 0.1 meter. 0.1 meter. Now minus 1 divided by 0.3 is equal to N2 minus 1 of 1 by infinity is 0. You have to remember. Minus 10 divided by 1 because multiplied divided by 10. 1 into 10 is 1 on 10 only. 0.1 into 10 is 1. So minus get cancels. Right? Now take the cross multiplication. N2 minus 1 can be written as this 2 minus get cancels. Cross multiplying this N2 minus 1 can be written as it is comes here. It is 1 divided by 10 into 0.3 is 3 only. So then N2, you transfer 1 to the right hand side. N2 is equal to 1 by 3 plus 1. So 1 by 3 plus 1 is 3 plus 1. 4 by 3. See, 4 by 3 means it is a water. They are not given water, just they are given a liquid. See here, they are given liquid. A liquid lens is formed. According to that data, it clearly says that liquid is water. So then the refractive index of the liquid N2 is equal to 4 by 3. Don't write unit for this one. So the refractive index of the liquid is 4 by 3. See, these problems are very important concepts. So while solving some of the NEET and CET, JEE questions, these concepts helps to simplify the problems. So that's why. So I kindly request from all the students, just concentrate and understand the techniques of solving these problems. So only thing is, in the board examination we have to write all the steps, but in the NEET and CET level, so final answer, the getting of final answer is very important. That's why, so we need to we have to try, we need to try the simplification without using calculator. That is very important. If you practice here itself, it helps in the examination of competitive examinations like NEET, CET and JEE. So I hope all the students can practice these problems 2 or 3 times and get ready for the examination. So I will go for the next problems in the next coming videos, that is related to mainly concentrated on total internal reflection. I will explain the problems on the basis of total internal reflection in the next coming videos. Thank you for watching this.